Exposure to at this conference, and this year we've been blessed with having two papers, so we're going to have another shot at the technology. Next up is Adam Ritchie, who's the Business Development Manager for Romeo Rim. He's going to talk about long fiber injection solutions and their disruptive fit in an unconventional industry. Adam graduated from Western Michigan University in 2005 with a Bachelor's of Science in Engineering. He started his career working as a design engineer for a military defense contractor. In 2010, he made a shift from product development to business development when he attained his MBA and landed a job as a sales engineer and then a program manager. Since 2014, Adam has served as business development manager at Romeo Rim, focusing on the agriculture and consumer product markets. He's been instrumental to the development and education within these markets of Romeo Rim's long fiber injection technology. Please welcome Adam.
This thing on?
You're on.
Thank you. Thanks, I appreciate it, Len. First off, thanks again for reaching out to us and getting us involved in this. This is amazing. And also, thanks for giving me the noon time slot, which makes me the only thing standing between you and lunch. So, I'll try to keep this short and sweet and get us back on track, right? All right, first off, I want to start with a little unconventional question. How many of you guys like guys and gals like waffles? Good? Waffles? Good. All right, this is going to seem a little vague for the moment, so I'll just put a pin in that. All right, as Len mentioned, my name is Adam Ritchie. I am Business Development Manager at Romeo Rim. I've got a background in mechanical engineering, so I'm not even going to pretend to know anything about chemistry. I think it took me 2 times to pass my chemistry class. I did get my master's in business, and that's when I made the switch to the dark side, as my engineers put it, to sales. And I've been at Romeo Rim since 2014, and it's been a great ride. They've been able to give me the opportunity to work within my passion of connecting people to the skills, ideas, and resources they need to be successful. So Romeo Rim, who are we? We are a composites manufacturer that focuses on creating partnerships so that we can develop and deploy innovative composite solutions that add value to all the stakeholders. We are located about 35 miles north of Detroit in the small community of Romeo, Michigan. We've got about 150 employees on site, shipping to about 90 customers worldwide. We are a trusted partner to some of the world's best OEMs, John Deere obviously being one of them, and just to clear the air, yes, actually in us, we do compete on a lot of things, so, but it's a good competition, right? We have 5 main markets: the agriculture and construction, heavy truck, mass transit, power sports, and the spa industry. You kind of see our split there. We are heavily focused on mass transit and paratransit. Our staple product is actually bumpers. Every U.S. Postal Service vehicle that you see running around has a Romeo Rim bumper on it. So that we developed that in the early 80s, and it's been a good stable product for that and mass transit. So we are a DCPD molder along with Ashley, and we also focus on in-mold painted polyurethanes. So that's the structural foams, and that's the solid elastomers, our bumper products, and the basis of today's conversation, LFI, or long fiber injection. So, what is LFI? How many of you guys know what LFI is, or have heard about it? Well, how many of you can spell LFI? So if I ever find myself in an opportunity where I'm at a party somewhere and somebody says, hey, what is LFI? Number one, I'm going to be questioning what kind of parties I'm going to. And number two, it got me thinking, how do I explain this to a layperson or somebody who's not in a technical background? So this is the best way I can come up with how to explain it. Waffles. We make big plastic waffles. So LFI is a low pressure compression molding process where we combine fiberglass and polyurethane into the back of a mixed head that's mounted onto the end of a robot. That slurry, as we call it, is then sprayed down onto the cavity of an open mold. Usually that mold cavity is painted. Then the mold is closed compressing the material, which forms all the B-side features, riveting, bosses. We can do some insert molding as well. So if a picture's worth 1,000 words, I think a video is probably worth 1,000,000. So I'm gonna hit the play button here and walk you guys through this a little bit. This is our new rotary carrier line for processing LFI. So that is the cavity of the mold that you're seeing there. And then the core side is up on the vertical. This is a paint robot that will paint the cavity of the mold, whatever color the customer desires. We have 6 current paint guns in that paint kitchen to do paint changes on the fly. This particular application is 2-tone paint, so we do a masking. That carrier, which holds the mold, then transfers down the track under the barrier coat robot or the protected polyurethane layer. This is a solid elastomer layer that prevents the fiberglass from breathing through the A surface when we do the compression. You can see it'll come down the track a little bit further under the LFI robot. And if you look closely, it'll happen quick. The woven rovings are fed into the back of the mix head, whether it's fiberglass, carbon fiber, or basalt, or some other, maybe the natural fibers. And then it gets mixed with the polyurethane. And then not unlike a waffle maker, the mold closes and the B-side features are formed as it starts to cure around the track. So we've got 7 of these carriers that travel around this track, so we keep polyurethane fiberglass pouring. And then finally the parts are demolded and the cycle is repeated again. So jump to the next slide here. So what does long fiber injection get us? What's it offer? So again, I mentioned the in-mold paint. That's one of our big value propositions. We don't have to post-apply paint on polyurethane. It's got a high stiffness weight ratio. We've seen somewhere between 700 and 800 KSI at 65 PCF. Now that being said, the material properties can be modified based on how much filler we put in it, whether it's glass or carbon fiber or whatever. And then we can also alter the density. So right now we're using a water-blown system. We can just reduce the water and make a full density LFI panel. So the material properties of LFI can be changed based on the customer's requirements, and sometimes on the fly. So if we had an area where we needed to put fiberglass concentrated in one specific spot, we can just shut speed the feeder up, and it'll put more fiberglass in that area. It's also primarily for large part manufacturing. So our double shuttle line can handle a part that's up to 12 feet by 12 feet, somewhere around a foot in depth, depending on the draft on the walls. And it's a 60-pound shot size. The rotary carrier line that you saw the video of can handle a part that's up to 8 feet by 4.5 feet, somewhere between 9 and 12 inches in depth, and it'll handle a 30-pound shot size. A variable wall thickness. As I mentioned, we have a water-blown system, so you can do ribs and bosses and variable wall thickness without getting synced to the A surface. Speaking of the A surface, it is an in-mold paint. So whatever's on the cavity of the mold is what will end up on the part. So if you have a high gloss mold, polished to an SPI A2 or A1, you're going to end up with a high gloss part. If you have wood grain on the cavity of the mold, you're going to end up with a wood looking part. This is an application you see there that we actually did both in one tool. So the tool's on the right, the part's on the left. So we had a high gloss polished area that the customer wanted it for accent, and then the rest of it's got just a standard empty grain on it. This slide and the next one are kind of where my engineering brain and my sales brain had a little bit of a battle. I couldn't sell you on all the benefits without telling you a little bit about the limitations of in-mold paint. Automotive high glosses seem to be a struggle for us with our current technologies. So getting above that 80 gloss on a 20-degree scale. In addition to that, pencil hardness. We use polyurethane paint, so that way we have chemical bonds between all of the layers of the system. Being that it's a polyurethane paint, it's designed to flex with the part. doesn't crack. You don't end up with stress cracks. But that also reduces the pencil hardness on the paint. In addition to that, we often deal with some of our customers with surface appearance hurt. So if you take an LFI in-mold painted panel and you put it next to Ashley's DCPD post-painted panel, there's a difference. Post-paint doesn't match in-mold paint. They never will, because in-mold paint will never have orange peel. And you can be the best painter in the world, but there's still that discontinuous difference. So I'm not saying it's a bad thing or a good thing, it's just something that we often have to deal with. So, that being said, there are some technologies that we are working on right now where you can actually take a thermoform sheet, and a lot like the toolless composite that Greg had mentioned earlier, you can take a thermoform sheet and backfill it with LFI to get it structured. So the thermoform sheet now becomes the A surface, and the LFI becomes the structure. We also do some panels in soft touch. I've got a stack of samples over there if you guys want to start playing with things. There is a soft touch sample to do like headliners, interiors of cabs, things of that nature. And you can actually post paint LFI with a low bake system. So, regarding the B-side features, as I mentioned, the core of the mold does generate the B-side. Actually, Len, I'm going to steal that one in your left hand.
Oh, sorry, I didn't steal it.
Your other left.
Okay, if I
Yeah, feel free to pass any of those over there around too as well.
Yeah, okay, great.
Thank you. That one's not a where was that? So yeah, we form the ribs and bosses with the B-side, the core of the mold. We can do some overmolded inserts as well. Again, the foamy agent that we put in it reduces that sink that you see through the A surface. And again, some limitations with that. Because we are spraying glass that is chopped at 1 inch in length onto the cavity of the mold, it's hard to get that glass to move up into a rib, especially if that rib is narrow. So we like to use the rule of thumb of 1/2 the length of glass. So if our glass is 1 inch in length, the base of that root or the base of that rib needs to be around 1/2 inch. That way we can ensure that glass will travel up into the rib. Any ribs that are taller than the parting line is another area that we struggle often with. Like any molding process, you got to worry about venting. You got to get the air out of the mold somehow, whether you're pulling it out or you're doing nitrogen blankets, whatever. But we vent to the parting line. So in order to do that, we have to keep all the ribs and bosses and everything below the parting line. Otherwise, we have to put venting in the center of the tool, which can be done, but it's a little bit cumbersome and they clog with material. It becomes a maintenance nightmare. So, the other thing too, like DCPD, we shy away from movement of the tool as much as possible. Actually, it's not even possible with LFI because it already has material in it when the mold closes. So once that mold closes, you can't actuate movement. So everything's got to be in line of draw. Again, I mentioned a lot of limitations, but those limitations usually can be worked around with collaborative efforts between the OEM and Romeo. We do a lot of design partnerships. And, I think Greg mentioned it, so did Zach, right? Leaning on those partnerships between the OEM and the supplier are imperative to success. You hate to see those SMC panels that Greg showed that were not very well designed. So, speaking of partnerships, I want to give you guys a little bit of a case study on a partnership that we entered in about 2015. So, just kind of show of hands, how many of you are involved or somewhere within the spa industry, the hot tub market? Nobody, I kind of figured that. Well, I think the best way for me to kind of walk you down this path is to give you a little bit of a history. Watkins Wellness and Romeo Rim, we partnered in 2015 to help them develop a new spa cabinet. Years ago, hot tubs came out of the factory looking like this. They were pieces of furniture that were made with real wood, cedar, redwood, hardwoods. They looked fabulous. But it didn't take long before they ended up a free ad on Facebook come fix it, come grab it, try to drag it out of my backyard. So it wasn't long before a lot of the spa OEMs went to polymer-based cabinets. So extruded polystyrenes, blow-molded polypropylenes. This was their answer to the maintenance-free cabinet. From about the early 90s until today, a lot of the spa OEMs focused on the wellness aspects of a hot tub. The lighting, the jets, the pumps, the energy efficiency. And it left a lot of opportunity for innovation on the cabinet, on the style, the design of this hot tub. So to answer that, Watkins Manufacturing is one of the world's largest OEMs of hot tubs. They're owned by Masco Corporation, which you may have heard or worked with. So they're an enormous organization. They partnered with, they contracted with BMW Design Works, and they developed this concept. And it was a complete transformation of what a hot tub could be. It came out, and it's now a focal point in somebody's backyard instead of something you try to hide your bushes. So they came up with this multi-dimensional design and started prototyping it. Their first concepts were injection molded pieces like this. So this is one of those vertical boards that you see there. So it wasn't long before they started realizing that assembling 50 of these onto a hot tub was going to be extremely cumbersome in their manufacturing floor, and they were going to have to start to make design considerations that they weren't willing to make. We got contacted by one of our partners that's in that area, hooked us up with a meeting with Watkins, and before long we started developing and designing a spa panel that could meet all of their design needs. Where that panel went. And they didn't have to compromise on any design. So what was the outcome of that? I'm going to put Brian's video, otherwise we would now. So after about a year's worth, a little bit under a year's worth of development, we ended up launching 14 tools in 4 months under 4 different product lines. So they have 4 product lines under the Caldera Utopia brand. We went from 50 part numbers down to 9. So now we make one solid side panel, 3 times, 4 corners, an access door, and an access door panel. So this partnership, as I mentioned, we're focused on partnerships, right? It provided Watkins the opportunity to keep their design intent without compromising on the side. It also allowed them to simplify their manufacturing process. They now receive one large panel that they stick a couple of clips on and it snaps onto the spot. And then on the reciprocal side of that, this program gave us the justification for that rotary carrier line. So we walked into that knowing that with Watkins, and they walked into it knowing that with us. So it was a reciprocal partnership. And that rotary carrier line has allowed us to reposition ourselves within the spa industry and other industries. We're now able to take the LFI process from 6 minutes down to 2. So we're pulling apart about every 2 minutes. Different molds, but regardless, we're still spraying LFI, we're still spraying material. So just a quick wrap up, and look at that, I'll keep us on time. I introduced you to myself, and I introduced you to Romeo. We talked about waffles. I told you about LFI, and I gave you a quick, reasonably compelling case study about partnerships and working together to develop those composite solutions. I'd just like to leave you guys with, what kind of waffles do you want to make? I really thank you for your time, and again, Len, thanks for putting this all together.
Great job. Questions for Adam?
Oh boy, here we go. So with your rotary system like that, and you've got different parts coming through constantly.
Yes.
So how well does that robot do with just almost different color change parts for part to part?
Yep, so there's 6 paint colors, actually 7 paint colors in that paint booth. So the robot knows by which carrier is coming, it knows what mold is set, and it'll go pick the right color based on the requirements that mold
Different
are.
head, a different head?
Yeah, there's 6 different heads that are lined up that we just pick, whether it's brown or green or blue or black.
Okay,
So,
that's a good way to do two-tone.
absolutely. Yep, that two-tone panel's running around here somewhere. Yes, sir.
Yeah, have you looked at DCPD and LFI?
Sorry, again?
Have you looked at DCPD and LFI?
So using the DCPD resin in long fiber injection?
Yes.
It has been looked at, but I can't say any more than that. I'll leave it at that. Yes, sir.
Is it a chemical reaction or thermal?
It's chemical. Yep. Otherwise, it wouldn't be the thermal cyclone. Yes, it's a A and B component, polyol and an iso. So it is.
It will be melted if you want?
Yeah, so the mix head, basically mix them all together, and then once it is sprayed down onto the cavity of the mold, that's when the chemical reaction starts to happen. So,
At the reaction we can.
no.
When you close the mold, do you have to put in any additional polyurethane material, or is it all ready to lock in water and put it allows your piece out?
The second one, we don't add any more material to it.
Okay.
Yep. Yeah.
Provides the rotary and automation for that area.
Who provided? Crossman 5. Yep. We actually bought that system from a company down in Texas that was using it for door skins. And we put a lot of money into revamping it with Crossman 5. And yeah, they built it up in their assembly or plant in Tennessee, Kentucky, somewhere. And then we moved it back up to Romeo. So, yes, sir.
And you might have covered this, I'm sorry. Was it steel or aluminum tooling?
Aluminum tooling. Yep.
And there's no, I mean, with the material expanding or,
Yeah, so-
in the tool, there's no surface degradation?
So the nice thing is the material only has about 50 psi internal molding pressures.
Okay.
So we have a lot of tune-in. Whenever we first launched the tool, we got a lot of tune-in trying to get the robot spray pattern just right, trying to get everything shot size just right to prevent those A-side issues. But after that, it's usually consistent. So.
That's really good. Good job.